Hello, in this video we will be discussing how to migrate from BackHome to BackBox using the BackCopy application. In this tutorial we will assume that the BackHome environment is known as QAT, the TSM environment is known as Q1D. Your backup set will be defined as a remote file with several execution dates, allowing you to specify the name of the remote file along with the date. We will be explaining how to migrate these backup sets to a regular tape environment. The trick is to make a new BackHome environment that will have a copy of the data from the TSM server to the regular tape environment. We will be going through these steps necessary to perform this migration. The non-stop tape infrastructure has a tape catalog called the DSM-TC. The DSM-TC will refer to every backup operation as a generation of a tape file. Tape files are written on tape volumes, and tape volumes are organized in tape pools. Let's take a look at an inventory on TSM. We can start the bint. We will use a QObey file to see the potential tapes we will migrate. In this environment, we have daily, weekly, monthly, quarterly, and finally, yearly. Let's focus on one group at a time. Let's look at daily first. We have 9 daily backups that we will be migrating in the following steps. Regularly, in BackHome, we are using non-stop programs to read and write to the disk. These programs access data and use what's known as the tape IOP emulation to write to the TSM server. If we wish to migrate from BackHome to BackBox, we will have to replace the restore program used normally with something known as the BackCopy program. This program will take a backup on the tape and write to a copy on another tape. In this case, we will be using BackCopy to take the TSM objects and copy them to tape for our migration. Let's switch to the BackBox UI now. In the BackBox UI, we have several volume groups. We define a volume group for each tape pool that we have in DSM-TC. When we move to the options in the UI, we will see DSM-TC, and we will choose the option to release the space when tape is scratched, vol, cat, and pool names defined along with the maximum size for a full backup on TSM. Now let's create tapes. Give a volume name, and in this example we're creating 12 tapes. Wait a little bit after you click create, and the tapes will be created along with the storage for the tapes and the entry in the BackBox catalog. When we move there, you will see that 12 scratch tapes have just been created. Normally, you'd mount the tape to write the label, but when you're using BackBox with the virtual tapes, it's already known by BackBox and a non-stop, and we are ready to use them right away. This is the program used for the migration. We will do a TSM query to find every generation of a given tape file backup, and with the parameters specified in this program, it will do most of the job. We specify the environment for BackHome, the TSM server, where is the list of objects to migrate, and we will also give a prefix for the request. We will have 2 requests for each execution of backup. Each request will start with the prefix ZD in this example, and we will create an obey file called dailyr to prepare those requests. In this file we will have a file cat, and a tape file will be used for DSM-TC4, the migration we plan on using. If you want to migrate all the generations of backup, keep this parameter last migration time commented. No need to update it. This is the execution of the program itself. It will run an obey file, creating the tape define for the daily tape, and then we restart the bmon. When bmon restarts, it will start backcopy to restore with the tape define. Let's look at start bmon. At the beginning of start bmon, you specify the object file used for the restore program. As you can see here, we're using the backcopy instead. So this means when we do a restore file, we're actually doing a backcopy of the file. Now let's run ogenreczd. This is the preparation for the migration of daily backups in this example. We queried a TSM server to find out the number of daily backups, in this case 9. And then we run the start bmon step of that script. After this, we need to sign on with the bint, and then we start the connection with the TSM server with that special environment. We run the obey file that the preparation script prepared for us. It creates 9 requests for the migration for backcopy and 9 requests for the update to the TSM-TC timestamp. We want to keep the original time of the files. So in this case, you can see ZD000 and ZD0000A to show the 2 requests working together to migrate the TSM object to the tape format. Now we have the tape file we will use. It looks like the usual restore, but instead we'll be using backcopy. Remote file shows the remote file to use, as well as the TSM server as the remote location as well. The normal end will queue the next request. In this case, it will be ZD0000A. ZD0000A will take the timestamp as a parameter and will change the execution of the backcopy we run. So instead of today being the date, we will have the original date and time that BackHome has. This makes it very easy to match the historical data. We will now queue the first request. It will start the process. The length of time of this migration depends on the size of and number of objects in your backup set. This could take days or even weeks to complete. Here we see in an accelerated video, we mount the tape and we use the tape to create that generation. When it's done, it'll update the timestamp and continue with the next tape. This is fully automated, and eventually we will have the job done. The job is now complete, and we'll be checking the queue list first. We check the list log, and we will see the tape files executed. You can see 7, and then 7A, 8, 8A, and then it shows it's complete.